Hello, my name is Felsheim. I am the Director of Headwall Photonics Europe and would like to introduce you to the Center of Hyperspectral Remote Sensing Europe. Hyperspectral imaging is a fascinating technology that precisely measures the spectral content of light in every single pixel of the scenery imaged. Analyzing this spectral pattern allows you to remotely identify and analyze the objects the light is reflected from. The potential of hyperspectral imaging is immense. For long, hyperspectral imaging has been well established in space satellites monitoring Earth. However, over the past years, optic and sensor technology, drones, as well as the required software to plan flights and analyze the spectral data have improved so significantly that hyperspectral remote sensing no longer is a technology only for specific specialists, but has become accessible for many applied applications. Headwall is one of the pioneers in hyperspectral imaging technology. Coming from creating hyperspectral imaging systems for space satellites, and still doing so, we are now offering complete drone-based remote hyperspectral sensing systems that no longer require trained scientists to benefit from the power of the technology. These turnkey drone-based hyperspectral imaging packages now open the door to a large range of remote sensing applications. The technology is proven and ready to use. We are very happy to have found a strong partner to support us in making this technology accessible to a wider user group, geo-konzept. Geo-konzept was one of the first who successfully brought advanced geo-positioning technology to standard agricultural and forestry applications, ranging from automatic steering systems to precision farming tools. Already yet, geo-konzept has excessive experience using drone-based sensing systems. In the beginning of this year, geo-konzept and Headwall jointly created a place to let you experience remote hyperspectral sensing, the Center for Hyperspectral Remote Sensing Europe. We want to make this exciting technology accessible and invite researchers, users, application developers, and other stakeholders to join in and realize the potential of remote hyperspectral imaging in whatever type of application, whether agriculture, foresting or mining, infrastructure inspection, environmental monitoring or surveillance. The Center for Hyperspectral Remote Sensing Europe is easy to reach. It is located just 1 hour north of Munich Airport on the premises of geo-konzept. It is surrounded by farmland, which are perfect to fly, offers mechanical workshops, meeting rooms, and everything needed, including ready-to-fly drones carrying hyperspectral imaging systems and licensed pilots to experience the value of hyperspectral remote sensing. Please join us and experience this potential in your application. We are looking forward to an open exchange with you, whether you are a researcher, an application developer, a farmer, a building engineer, or run an open pit mine. Whether you need to monitor experimental fields, environmental status, or investigate the status of a bridge. Please come and join us for our webinars, or as soon as the COVID-19 crisis allows for again, our on-site workshops, or contact us and ask for a video conference to address your specific need. We are looking forward to discussing your hyperspectral remote sensing application with you. And with that, please allow me to hand over to my colleagues to tell you more about hyperspectral imaging applications. Thank you.
Hello, my name is William Rock, and I'm an applications engineer at Headwall Photonics, and today I will be giving you a brief introduction to hyperspectral imaging and airborne push-broom remote sensing. So, what is hyperspectral imaging? In simple terms, it is the combination of imaging and spectroscopy. For those of you that may not be intimately familiar with spectroscopy, what does that mean, or what is another way to think of hyperspectral imaging? Well, regular imaging, like with your camera phone that everybody's used to, is like taking 3 pictures, a red picture, a green, and a blue. Those 3 pictures are put together to form a regular color image like we are used to seeing. Well, hyperspectral imaging is like taking hundreds of pictures at slightly different colors and then using all that information to get better contrast or to see things that your color imager might otherwise miss. It can also be used for chemical discrimination or even regression analysis to figure out some numeric things about your data as well. All objects will have a spectral fingerprint, and that is how that object will absorb or reflect light. So for instance, if something blue reflects light, it will reflect mostly blue light. And so if we look at that on the spectrum, it will look something like the spectrum that you see at the left, and it's blue because the light around 450 nanometers is brighter than the rest of the light that we can see, and so therefore it will appear blue to us. Something that is red will reflect more red light, and this is what a red spectrum will look like because it is reflecting more light around 600 nanometers, or what looks red to us. And then finally, something green will reflect more light in the green area of the spectrum, just above 500 nanometers or so, as you can see on the spectral profile to the left. So these are just 3 example spectra, but you can see how qualitatively different those spectra are, and that is also how hyperspectral imaging can be used to tell the difference between 2 things that both look green but are in fact slightly different. There might be different areas of the spectrum where they're wildly different, and that will allow you to utilize hyperspectral imaging to tell the difference between objects that look quite similar for regular imaging. And again, that is just one of the ways that hyperspectral imaging can be used for a variety of other analyses. Headwall's hyperspectral imagers are what are called push broom imaging spectrometers. This is just an airborne image of a scene. A normal camera will divide that scene into a bunch of different pixels, and you'll take a picture of it and it will look something like what I've shown to you here, a normal, what we would call a 2-dimensional image. Well, Headwall's imaging spectrometers, because they're collecting all of this extra spectral information, look at the world through a slit. And when you're looking at a world through a slit, of course, you're only collecting a fraction of the scene every time an image is gathered. And this is done so you can also gather all of that spectral information. Instead of, again, taking those 3 pictures, you're taking hundreds of pictures. And so those hundreds of pictures are put onto the camera all at the same time along one small slit. And so for your data collection, how do you collect a whole large area or a large scene? Well, you need to fly or move over the scene. And so Headwall's push broom imaging spectrometers on a drone or an airplane will collect a new picture every time the sensor moves one spatial pixel. And so you can see the direction of motion here, as is seen by the arrow in the bottom left corner of the screen, is the direction of flight. And every time that drone moves one spatial pixel in space, a new sliver of the scene will be gathered until a whole image is built up. And at every spatial pixel, there will be an entire spectrum. And one other thing that I like to note that is true for any form of imaging or any form of remote sensing is that there's always a trade-off between the field of view and the resolution. So if you have a small field of view, you will have a higher resolution, and if you have a larger field of view, you'll have a larger resolution. And the easiest way to toggle between small field of view and high resolution and large field of view and low resolution is by changing the altitude at which you fly. This slide shows that with a little animation here. So when the drone is close to the ground, you can see that a wide field of view, or when the drone is high in the air, you can see that a wide field of view is covered, and when the drone is close to the ground, you can see that a narrower field of view is covered. Finally, I like to show this graphic here to help maybe give you a better picture of what it's like when the drone flies over a scene and collects these hundreds of pictures of the scene all at the same time. So here, again, is a picture of the focal plane like I've shown in my previous slides. And now if I just turn the focal plane to the same direction that we're flying, every time the drone moves one spatial pixel, a new focal plane is collected, a new image is gathered, which will again be all of these hundreds of images along one sliver of the scene. And as the drone flies across the scene, the entire 2-dimensional image will be gathered with hundreds of images at every spatial pixel in the scene. And so, in summary, as a brief introduction to hyperspectral imaging is a combination of imaging and spectroscopy, and hyperspectral data can be used for a wide range of detection applications, and software and hardware advances are quickly helping hyperspectral imaging transition from research into industry, and that is some of what my colleagues will talk about later in future sessions. And Headwall is also a leading designer and manufacturer of complete spectral instrumentation solutions for remote sensing, which will be most interesting to the people in this audience, but also advanced machine vision and government and defense markets. And Headwall also expedites progress by providing turnkey airborne hyperspectral imaging packages that are ready to fly the day they arrive. Thank you for staying tuned, and please listen to my colleagues as they tell you more about how hyperspectral data can be exploited in remote sensing.
Hello everybody, also very warm welcome from my side. Thanks a lot Christian for the introduction in the Center of Hyperspectral Remote Sensing Europe, and Bill for the introduction in the hyperspectral imaging and also in the UAV solution from Headwall Photonics. Now I'm very proud to present you all our software solution, what you can do with this with the result of the hyperspectral imaging. That are not only very nice colorized images, they have included a lot of information for your applications. Please let me first introduce myself. My name is Christoph Schimmer. I'm working for geo-konzept in Germany. I'm one of the international sales manager in our remote sensing department, and my main field applications are on the one hand remote sensing and multispectral hyperspectral imaging, GIS survey, and I'm also a licensed UAV pilot. I studied diploma geography at the University of Augsburg, and I'm at geo-konzept since 2011. Who is geo-konzept? Geo-konzept is based in the southern part of Germany between Nuremberg and Munich, in the small village called Adelsschlag. It's the headquarters from geo-konzept. The company was founded by the founder and the CEO Thomas Moore in 1992. And at the moment we have more or less 16 employees. And our main application areas are agriculture and precision farming. We are partner for Topcon solutions, also quarry and open pit mining and blast design solutions. We have also a department for MGIS solutions, and last but not least, also the remote sensing department, which one I'm part of it. Now I'm very proud to show you one of our software solutions. It's called COGIS. COGIS is our own GIS software solution and was born in the year 2011. And we have the development in our house. And one of the main applications of COGIS is the planning, mapping, and evaluation of georeference data sets. And one of the big pros is that the data are in the real world coordinates. And last but not least, you can work with the data and also export in machine-readable format like Topcon and Trimble displays in ISO XML, KML, shapefile, CSV, or TXT. On the bottom, you can see a hand of some add-ons, which one you can use in COGIS. One is the basic add-on, which one showing you GIS data and GNSS position. The counting add-on is to count different or single plans. The mapping solution, you can connect a GNSS receiver to COGIS, and you can digitize polygons, lines, and points, whatever you want. And last but not least, here my presentation is the scoring module. The scoring module is important for you to calculate with different vegetation indices. First, I want to show you as a mapping module, and the mapping module can, on the one hand, used for digitize field boundaries, and you can see in the screens or in these images, it is very easy to click on a background map to the borders from a field, and you can close it very easily to a polygon, and you can use this polygon as your field boundary. And it's only a few clicks to generate your field boundaries or area of interest. What can you do with this polygon? You can use this polygon to cutting out your field or your area of interest from a bigger data set, and you can only analyze the data what you want, what you need. And for example, on the right side, you can see a cornfield is in the middle of the United States. And it was collected by a UAV flight with the co-align system from Headwall Photonics. And it's in the V-near range, in the spectral range between 400 and 1000 nanometer. And with you will get more than 270 channels, reflections from the vegetation, for example. What can you do with the data? On the one hand, as I told you, you can very easily calculate different vegetation indices, which one you can see, for example, on the right side. It's only a simple example. It's a NDVI vegetation index, or you can also create colorized georeferenced orthophotos. You can see also on the right side. One of the big advantages of CHRSE is you have an open index calculator. You have not only a fixed number of vegetation indices, which one you can calculate, you can choose your own vegetation indexes, and you can use it as raster calculator what you want, and you can use it for your applications. Last but not least, I want to show you a very easy way to create an application map, which one is most interesting for farmers to use it in a machine readable format. And the application map is, in this case, is based on a georeference vegetation index map. You can see on the left side, and you can create very easy in a few clicks homogeneous zones with the same spectral reflectance. And you can choose the number of zones, the size of the zones, and it's free and adjustable by the user, and it's not in a black box. It's all the settings can done by the user itself, and the result are the most interested machine readable data set, which one you can export to TopCon Trimble displays, to ISO XML, to KML, shape, CSV, or TXT file. To summarize the CHRSE software solution, the CHRSE is a Windows-based software system. You don't need internet connection. It's not a cloud solution. It's no cloud connection necessary. You only pay it for once time, and you can unlimited usage. And of course, we develop it all the time, and you can also purchase an annual and optional updates if you want. And all the modules which are available for CHRSE are free combination and relevant modules. Thanks a lot for your attention. If you have any questions, please let us know or write an email. Thanks a lot and have a nice day. Bye.